Welcome, everyone. We'll give it a minute or two, let everybody log in to the webinar for tonight. I'm Robin Broder, Deputy Director of Waterkeepers Chesapeake, and we'll get started in just a moment. All right, just a few little housekeeping things before we get started. This is a webinar, so all the attendees are muted and your videos are off. If you have any questions for our panelists this evening, we would love you to put them in the Q&A box at the bottom of your screen. And feel free to introduce yourself in the chat if you would like to do that, so we know who's with us this evening. And this is being recorded, and we'll share it with everybody who registered for the webinar this evening. I would like to thank Mom's Organic Market for being a sponsor of this event. And now I'm going to turn it over to Jesse Iliff, who is the Southwest Road Riverkeeper, and he will be our moderator for tonight. Thank you.
Thank you, Robin. And I reiterate the thanks to Moms for the sponsorship, and especially want to thank our panelists for participating in this event to discuss a very important issue that I knew very little about until recently. But for those of you who are like me and a bit in the dark, PFAS chemicals are carcinogenic chemicals. It represents a family of thousands of different chemical compounds that are found in a number of consumer items, from non-stick pans to Gore-Tex jackets to firefighting foam, even personal care products like mascara and sunscreen, things that are intended to repel water. The letters stand for per and polyfluoroalkyl substances. And because of the ubiquity of these materials and the danger they pose, we have a couple of intrepid lawmakers with us who have sponsored legislation to phase these out. I was thinking when I was going to introduce these two lawmakers that I would list the environmental bills that they've sponsored, but it became apparent there were too many to go through in the limited time that we have. So I'll just name a few from this year. Our first panelist would be Delegate Sarah Love from District 16 in Montgomery County. And in addition to the PFAS bill, just this session, she's sponsoring legislation to prohibit the chemical conversion of plastic, to institute a beverage container deposit program, and to restrict certain single-use plastics in restaurants. It's this sort of work that has garnered her a 100% A+ score with the Maryland League of Conservation Voters, and we're delighted to have Delegate Love here with us tonight. We're also welcoming Senator Sarah Elfreth from District 30 in Annapolis, my home senator. In addition to the PFAS legislation, Senator Elfreth is sponsoring bills related to updating stormwater management regulations, to improving transparency and environmental enforcement in the state, and the Clean Water Commerce Act to make good use of our Bay Restoration funds. And she also enjoys a 100% score with the Maryland League of Conservation Voters. So in addition to our lawmakers, we have three experts on the subject of PFAS. First is Vicki Blazer, a research fishery biologist with the United States Geological Survey. She'll be presenting about the presence of PFAS and smallmouth bass in the Bay. Next, my own comrade in arms, the Upper Potomac River Keeper, Brent Walls, who's been with Potomac River Keeper Network since 2009, will be doing a presentation on the monitoring of PFAS that he did in the Upper Potomac a couple of years ago. And last but certainly not least is Anna Kilias, a policy analyst from the James River Association, doing a presentation on the PFAS testing and regulation infrastructure in the state of Virginia, or the Commonwealth of Virginia. So without any further ado, I think I'll hand it off to Delegate Love to explain a little bit more about the bill that is currently before the Maryland General Assembly. Delegate Love.
Thank you, Jesse, and thank you for that introduction. If you don't mind, I'm actually going to flip the order and have Senator Elfreth go first. So if that's okay, Senator?
By all means.
That's great. We're otherwise known in the General Assembly as the Sarahs, or the Sarah Squared, because I have the absolute privilege of working with Delegate Love on this bill, as well as our stormwater bill that so many water keepers and environmental advocates crafted, to be honest. And we're just carrying that water for the next 90 days to get it passed. But I'm so happy to be here. And Jesse, I love claiming you as my water keeper here in Anne Arundel County. But for folks I might not know, my name is Sarah Elfreth. I have the privilege of serving as the senator from Maryland's capital city, the 30th district, which is Annapolis and South County. I'm so excited to be here tonight to talk about what Maryland can do to better address this issue of forever chemicals. We made a little bit of progress last year. We passed a bill. Actually, it was an homage to our friends in the Commonwealth of Virginia who passed it first, but a bill that prohibits the use of PFAS, or forever chemicals, in firefighting foam for training purposes. And so we got that across the finish line last year, even in an abbreviated session. And Delegate Love and I have the privilege of serving on the Chesapeake Bay Commission. I got to say, up until recently, Maryland was the only member of that commission, which has the Commonwealths of Pennsylvania and Virginia. Maryland's claim to fame in the last couple of years is we're the only ones that send women to that commission. And I was so thrilled to be joined by Delegate Love on the Chesapeake Bay Commission. But we knew we needed to do more, and we knew we needed to add Maryland to the list of states that were taking a very serious look at where these PFAS are, where they're coming from, and what we can do to safely dispose of them and keep them out of our waterways and keep them out of our bodies and out of our environment. And so Delegate Love is the one who really crafted this bill. So she's going to carry the water on explaining it better than I can. But it's our goal here was to put Maryland on the map of having this conversation. Many other states are having this conversation. It's an issue in Congress right now. We're hoping that if we make this critical mass of states that are taking this issue more seriously, and we put the pressure on where we need to put the pressure, we're already seeing the market respond in a very positive way. We're seeing major corporations shift their use of PFAS in food packaging, in selling carpets, and et cetera. We're seeing that market react. And so the bills they've been heard in the General Assembly, in the Senate, and the House. They're awaiting the committee work that's ahead. But I'm just very happy to be here and be a part of this discussion. And I'll kick it back over to my partner in all of this, the other side of Sarah Squared, Delegate Love.
Thank you, Senator. Always a pleasure to be with you. The honor is mine as well. Love being here with you all. And Senator Elfreth gave a shout out to the water keepers. You all do such amazing work, and we are so appreciative and happy to support you in any way that we can. Our firefighting, our PFAS bill, as the senator said, built on the firefighting foam ban last year. And it really does take its inspiration from around the country. So there are three main sections to this bill: source reduction, disposal, and working with the Maryland Department of Environment on a PFAS action plan. So with respect to source reduction, we looked at foam, rugs and carpets, and food packaging. So this year we took foam to the next level and went with a full-on ban. At least 5 states have banned the use of firefighting foam with intentionally added PFAS, as has Australia. The DoD is phasing it out, and we had firefighter support. So it was something they're very committed to and feel very strongly about. So we were honored to have their support on our bill. The second part has to do with rugs and carpets. The thing about PFAS is it creates this barrier with grease. So as Jesse said, it's in so many things. It's on rugs and carpets to make them stain resistant. And so our bill would prohibit the sale or manufacturing of rugs and carpets that contain PFAS. Vermont is looking at this legislation. As the senator said, the market is also reacting. IKEA has eliminated it in their textiles. Home Depot and Lowe's have announced their commitment to end sales of carpeting treated with PFAS. And then the last point on the source reduction is the food packaging. This one's a little scary. I mean, you think about the microwave popcorn or the inside of your soup can, or so many other things that are non-stick surfaces. So this again would prohibit the sale or manufacturing of food packaging that contains intentionally added PFAS. 3 states, Maine, New York, and Washington, have banned PFAS in food packaging. And again, the market is responding. Giant, Whole Foods, Trader Joe's, Food Lion, Stop and Shop, and many, many more, including fast food. McDonald's, Chipotle, Taco Bell, I could go on, have all made commitments to phase out PFAS food packaging. With respect to the disposal, we worked with some folks up in New York and worked on modeling our bill after their law that would ban the incineration of firefighting foam with intentionally added PFAS. And then we took that and added banning the landfill of it, because neither one of those is safe for our environment or for our health. And then the last piece includes uncodified language. I know you're going to talk about the MDE work group later, but it talks about having MDE create this PFAS action plan and testing and remediation and working with the Maryland General Assembly. So that's an overview of what our bill does, and I'm happy to answer any questions. And thanks so much to all of you and to Senator Elfreth.
Thank you, Delegate Love and Senator Elfreth, for breaking down what the mechanics of the bill do and some of the impetus underlying, motivating it. We do have a couple of questions that have already popped up, and one I think is probably best directed to the two of you as lawmakers. One of our friends from Pennsylvania asks, what might be done to motivate lawmakers in Pennsylvania to adopt similar legislation? Apparently, there are a cohort of folks up there who have been asking / demanding that sort of action and seeming to not get the movement that they wanted. So if you have any input there, I'm sure it would be appreciated.
Senator, do you want to start with that?
Sure. I really appreciate this question. I have learned so much in my 2 years on the Chesapeake Bay Commission, working with our colleagues in Pennsylvania. One of the most important lessons learned is how their government structures differ from Maryland's, and how that then impacts a lot of their particularly environmental policy when they have a significant amount of municipalities. For instance, here in Maryland, we have 57, in Pennsylvania, and something like 2,500. So imagine all of the little fiefdoms of mayors and town councils making environmental policy and zoning decisions complicates environmental policy to a great degree. And sometimes we forget, we're so focused on the Bay here in Maryland, but in Pennsylvania, it's about the streams and the rivers. It's about that they have so much more density when it comes to the water quality of those streams and rivers that are then draining down into the Bay and into the Delaware River and other estuaries and watersheds. But really focusing on local stream health seems to be a better approach in Pennsylvania. Just working with our colleagues in Pennsylvania, making it about their own backyards, and why this stream being impaired, and something like 50% of the streams in Pennsylvania are impaired, making it and focusing it on the local is a really good tool to get the Pennsylvania legislature to care about this issue. Another good lesson learned is there's 3 watersheds in Pennsylvania, the Chesapeake just being one of 3 major watersheds. So focus is a little more disparate in Pennsylvania than it is here in Maryland, but really localizing it, I think, is a good approach generally to things in Pennsylvania.
The only thing I would add is if you're in contact with your Pennsylvania legislators, please let them know that Senator Elfreth and I are always happy to talk to any other legislator and talk through our experience and how we put our bill together and why.
Thank you for that feedback. I think going with the local approach and chipping away at it is a good strategy. Another question about the legislation asks whether there are any plans to identify which food packaging products contain PFAS or PFASs, and notes that currently it's difficult to tell, particularly with takeout containers, whether there might be anything in those containers. So can you speak to that?
Sure, there are a number of organizations that are doing that testing, and just a quick Google search and you can find them. You know, Maryland PIRG has put up a lot of information about it, as has, oh no, I'm blanking. Senator, what's the other? Oh, Safer States is the other one I was thinking of. So they've done a lot of testing, and it's interesting because companies themselves are actually coming forward and saying, okay, we're no longer going to use this. It's, you know, it is very hard for individuals to know what companies use this and what packaging use this. So some of these resources I would recommend is the best place to go to find those things out.
Thanks. And another question was, is there a fine structure in place or a penalty structure in place if the requirements of the legislation aren't followed? I
think we're both looking at each other, seeing which one is going to take this. Senator, you want to take this? You want me to?
Well, I'll say we did think long and hard over the interim about penalties and how to and enforcement. You know, I teach public policy, and I don't even know how to explain the complication. If we added that, it would have caused the bill to be jointly assigned to the judiciary and the JPR committees, which would have made passage significantly, I mean, I can't overstate, significantly more difficult, particularly in this session when we kind of have COVID hovering above us and we're not sure how long we can be here, and we're limited to floor time at 2 hours per session. So we really did think about the implementation, and we wanted to add that, but we also didn't want to hinder the bill in any way. By adding that, it would have been jointly assigned. It would have needed a whole extra step in this process that we only have 90 days to solve. That's my long-winded way of saying not in this bill, but it's something we thought about and want to approach in the future.
Thank you. A kind of follow-on question was, does the bill have a sunset clause? Is there an expectation that all of these things will be phased out by some time and then the bill goes off the books? Or is it just on the books and let's hope that they're all gone eventually?
It's on the books. There is no sunset. And the reason for that is there are somewhere in the vicinity of 9,000 of these chemicals. And what we're finding with the chemical industry is once EPA figures out the danger of one of these chemicals, then the chemical industry just changes one portion of it and uses another one. So you've got to do it on a broad based approach and keep it on the books so that they can't tweak something and go on endangering our health.
Thanks. That absolutely makes a lot of sense. There was another question about, with apologies for being late, but is there an update on the status of where the bill is in committees? And does anybody, need a phone call or an email to try and get convinced to help it pass?
Sure, I'll take this. We had really strong hearings. We had some opposition from the chemical companies, but we knew we were going to have that. I think we had a lot of support. The delegate mentioned the firefighters, Marilyn Perg, a lot of public health experts. I can speak for the Senate. The Education, Health, and Environmental Affairs Committee is trying to triage their work. So this week they're very focused on the Climate Solutions Now Act, the Clean Water Commerce Act, which are very important bills and taking up a lot of time. I believe they're on the voting list for tomorrow. So once we get past those major environmental bills, I have confidence they'll take up this bill. We have, it feels very urgent, but we do have a little bit more time. And I would always encourage folks to reach out to their representative. I know we always want to reach out to everybody on the committee, but I would be remiss if I didn't tell people we are under an absolute avalanche of emails, and we didn't get any more staff this session. And we're dealing with about 1,000 emails a day, which is very, very difficult for our staffs to keep up with. So we focus on my constituents who reach out to me. So I would really encourage folks to reach out to their representatives, regardless of whether they're on the committees or not of jurisdiction. We want to hear from you if we represent you. So please reach out to the folks who represent you.
Same thing on our side. Legislators want to hear from the people they represent. And those are the people that I respond to. On the delegate side, you've got 3 of us. So reach out to all 3 of us because we want to hear from you. The Health and Government Operations Committee, like in the Senate, very strong hearing. We had our opposition. And like in the Senate, they are triaging their work. There's a lot of COVID work that they're dealing with. There's a lot of telemedicine that they're dealing with. So we're hoping that they will have the bandwidth to take this up and pass it this session. If not, then I know the senator and I are committed to keeping the focus on this and to keep working on this.
Yeah, Jesse, I'll just add to that. Delegate Love and I approach this as this is a pretty big bill. And unfortunately, our process generally, but specifically here in Maryland, when we have a 90-day session, it might take a couple years to get a really big bill done, but we wanted to make sure we had really strong hearings this year. We put this on the radar for a lot of legislators, and we have to leave it up to the committees of jurisdiction. But this is going to be a multi-year effort, regardless of whether we pass this bill or not. There's still a lot of work to be done. So we're committed for the long haul.
Great. Well, that's encouraging to hear and totally unsurprising knowing what I do of you two. Thank you for the work to move mountains. Most of the questions that are left in the Q&A box are sort of more on the technical side. We want to be mindful of your time and thank you for giving it to us this evening. You, of course, are more than welcome to stick around for the rest of this panel discussion, but I think it's appropriate at this point. One thing on lawmaking and sausage making, if you want to contact your legislator, but you're not sure who they are, the map to find that out has been linked in the chat box. So if you don't know who to direct a missive to, now you can find out. But since the remaining questions in the Q&A box are on the more technical side, I think we could probably move on to our other panelists. And thank you again, Delegate Love and Senator Elfreth, for being with us tonight. I guess without any further ado, I'll hand it off to Vicki Blazer to tell us about how the PFAS are affecting the fish.
Okay. All right, so I'm going to talk about some of the work we've done looking at plasma of smallmouth bass. Next slide, please. I'm also going to take my video off because it says my internet connection is unstable. So we've been looking at smallmouth bass for quite a few years, as well as other fish species, because of a variety of health issues. In the Potomac, we've seen adult mortality, skin lesions, and intersex. And up in the Susquehanna, we see intersex as well. There it was young of year mortalities. And in both places, in certain areas of both the Potomac and the Susquehanna, we are seeing population declines. Next slide, please. So this all got us in USGS involved in a long-term monitoring program where we started in 2013. When we started, we had funding for 6 sites with varying land use. We're now down to 4 sites. And it really was focused on endocrine disruption, although we've looked at a lot of other disease issues. So just quickly, we focused on agricultural land use because that's what we were seeing associated with the intersex. We collect adult fish in the spring and the fall, and young of the year in the summer. And we've looked at a whole range of biological indicators from external and internal abnormalities, microscopic pathology. We collected blood and plasma. And we're also looking at a variety of molecular endpoints. And then in 2016, with a graduate student from WVU, we started looking at actual immune function assays in these fish. Next slide, please. Like Jesse mentioned, PFAS, I wouldn't sell myself as an expert on PFAS because it's sort of a new thing that we've started looking at. But because of the interest, both from USGS and other, the river keepers and other people, we actually used plasma that we had archived from all these collections we've been doing. And one of the reasons we wanted to look at PFAS is that many of the things that we're seeing in the fish, immunomodulation, oxidative damage, chronic inflammation, reproductive endocrine disruption, dysregulation of thyroid function are some of the things that have been attributed to PFAS exposure. Next slide, please. So we started out not knowing whether we were going to see anything in these fish, and we used the 2018 plasma samples we had from those 4 sites and both spring and fall collections. We had 13 different compounds analyzed for. As has been mentioned, there are thousands of these chemicals. So there's a company in British Columbia that ran this for us. Next slide, please. And what we found was for 4 of these compounds, they were detected in every single plasma sample that we looked at. PFAS, the PFOS, was by far the highest concentrations at all the sites. And you can see that it ranged up to 574 nanograms per ml. That's a pretty high level. It's a very high level. The other 3 were at much lower concentrations. And then we did also see two additional compounds that were found just in some samples. One of the things to note here is that all of these are the longer chained compounds. And that has been shown previously that those are the ones that tend to bioconcentrate as well as biomagnify up the food chain. Next slide. So as far as site differences, as I said, PFAS concentrations were the highest ones we found. And what I'm showing here is means of those compounds. And I see that my letters are off a little bit, but basically the highest concentrations were at Antietam Creek. The second highest was at the West Branch Macantongo, which is in the Susquehanna drainage. The third was the South Branch of the Potomac, close to Moorfield, West Virginia. And then Pine Creek was the site we had. It's primarily forested, and it's somewhat of our reference site. So all 4 of those sites were significantly different than each other for PFAS. For the other 3, Antietam was significantly higher than West Branch Macantongo, and then Pine and South Branch were not different from each other. Next slide, please. We also looked at whether there's any difference between sex and, well, first we looked to see whether age was a factor. Remembering that the fish that we're collecting are adults, so they're from 2 to sometimes 8 or higher years old. We didn't see any difference in age between males and females when we combined all the sites, nor did we see a difference in PFAS or PFDA. 2 of the other compounds were significantly higher in males than in females when we combined all the sites. And actually, when we analyzed by site, the findings were somewhat similar. Next slide, please. We're also really interested, because of these differences that we've seen, in trying to understand land use attributes and also using that to hopefully tease out sources. So as I said, we initially started this project more to look at agricultural effects, and Pine Creek was our primarily forested, which has low ag, low developed. West Branch Macantongo, moderate ag, moderate urban development. Antietam Creek is the one that has the highest ag as well as the highest development. And then South Branch is also moderate as far as agriculture and low as far as developed. We're looking at both the upstream cumulative drainage as well as the immediate catchment. And the reason for that is that, as you can see, these watersheds differ a lot in size. So Pine Creek and South Branch are larger drainages, and Antietam Creek and West Branch Macantongo are smaller. The other thing I'll point out is that for all 3 of Pine Creek, Macantongo, and Antietam Creek, we're collecting fish right at the mouth of those tributaries. And so we do know that fish are moving in and out of the creeks into the main stem of either the Potomac or the Susquehanna. South Branch is a little different because that's about midway. So those fish are probably not ending up in the main stem of the Potomac. It's not showing up. For some reason, my slides are a little off on this, but basically what I wanted to show is that when you look at the landscape characteristics, we're seeing very similar patterns to what we see with the patterns of the PFAS concentrations. So the sites that are higher in ag as well as development are having the highest concentrations in the plasma. Next slide, please. Based on what we had found, that made us think that there's probably something we ought to be looking closer at. So we have just recently gotten data back from plasma samples from 2017 and 2019. This is allowing us to look at a temporal analysis at these sites, but also it gives us a much higher sample size to try to tease out some of the biological endpoints. We also submitted plasma for additional sites to get a larger spatial analysis in the hopes that we can understand sources better. Next slide, please. So as far as the more spatial, on the left, I just graphed out the PFAS, not the other compounds. The one at the very left is another site in the South Branch. It's close to Petersburg, a little lower concentrations than the South Branch, close to Moorfield. Antietam Creek, as I mentioned, is one of the higher ones. Then Chillisquawkee Creek, which is up in a tributary of the Susquehanna. Swatara Creek actually had the highest concentrations we've seen. And some of those fish were above 1,000 nanograms per ml of total PFAS, which is high. So Tar Creek runs through Hershey, and it also, there is a National Guard base close by there, so that could have an effect. We also looked at one of the main stem Susquehanna sites at close to Sealands Grove, and that was similar to the West Branch Macantango, and those are close to each other, so that's not surprising. And then Pine Creek was, as I said before, the lowest. That's the forested site. I also have started looking at the temporal, and I'm just showing Antietam here for an annual comparison. And it does look like there's some increase between 2017 and 2019. Again, we need to do a lot more statistical analysis to start teasing some of these things out. Next slide, please. So what we want to be able to do is start teasing out some of the potential effects. It would be good to look at some other fish species as well, because from the literature, we know that fish differ a lot in bioaccumulation and/or biomagnification. In general, these apex predators like smallmouth bass do tend to have the highest concentrations. It's a little difficult to compare our work with some others that have been done using bass and similar species, because most of the studies look at mussel or fillets because they're concerned about human health issues. There have been a few studies where they've compared tissues, and they do find that plasma or blood tends to have the highest concentration, liver the next highest, and then mussel less. When you look at our concentrations for studies worldwide that have analyzed blood and plasma, our results actually are some of the highest that I've found. Striped bass from Cape Fear, North Carolina, which was downstream of a PFAS production plant, was slightly higher. The problem trying to tease some of these effects out, though, is that wild fish are exposed to a lot of things, not just PFAS. And so what we're hoping is by looking at all these fish health indicators, we have a lot of chemical analysis of surface water that we can begin to tease out what are the most important risk factors and where does PFAS really fit into this. There have been some surface water analysis. Brett's going to talk about some that have been done in Maryland. We're also working with Pennsylvania DEP because they've done a huge amount of sampling in the last year or two of surface water. And so we want to look at what if they have information at the sites where we're collecting fish. Next slide. I think that's the end. And so I don't know if do you want me to take questions now or wait until after Brett's?
Yeah, so a couple of questions did come in, but I think we'll move forward and do Q&A at the end. The questions are there in the Q&A, they're written down, so we won't miss them. Okay. Thank you for a very interesting and somewhat concerning presentation, Vicki. Brent, you're up.
Great, I'm on deck. Excellent. Welcome everyone to the PFAS show. We're here to educate you on all kinds of things that concern our health. And, you know, I want to kind of go on a little bit of a timeline to just kind of describe my experiences so far, because PFAS was not in my agenda for the past couple of years. It has been, though. And in 2016, Environmental Protection Agency did issue a drinking water guidance for PFAS, and that was 70 parts per trillion, which is a combination of two very specific substances of the PFAS family, which is about 9,000. I think that's the latest tally. And that is PFOS and PFOA. And you've heard Vicki talk about PFOS and others. The delegates have talked about PFOS as well. But those are the two particular ones that were in the drinking water guidance of 70 parts per trillion. Well, a lot of facilities across the country then did violate that drinking water guidance. And it's not a mandatory shutdown, but those that did felt the need to shut down and make some changes. And Martinsburg here in West Virginia was one of those facilities. And they have two different sources of their water. One is a spring, and that'll come into context here in a few minutes. So after that, the Department of Environmental Protection West Virginia sampled in the spring. They sampled some private wells, they sampled some streams, and they came up with some alarming numbers. And what they really came up with was that there was a source, and that was the Air National Guard base in Martinsburg. They have used AFFF firefighting foam for the past, for several decades. It's an aircraft facility, and that's a lot of training. And that has soaked into the ground and gotten into the springs, which is one of the sources for the Martinsburg water treatment plant. Now Martinsburg did finally upgrade in 2017 and completed in 2018, and so they're on par. What's also interesting to note is because of that situation, the CDC and the Agency for Toxic Substances and Disease Registry, long acronym ATSDR, began an exposure assessment, not just here at Martinsburg, but it's at several facilities across the country. And they came up with some alarming information. What they were doing is collecting blood samples and urine samples and doing home inspections, about 300 volunteers that drink the water there at that public source. And that's when we got involved, and we said, you know what, I need to do some follow-up and trying to figure out really what's going on and have some of my own numbers. And so we did some sampling in 2019. Next slide. So on the road to sampling for PFAS, we did. In February of 2019, we sampled a couple of private wells in the USGS well, kind of for a reference situation. And, we got some interesting numbers too, to 6.6 parts per trillion PFAS. And that was a combination of PFAS and PFOS and PFAS. And so, or PFOA, I should say. And so that was a little bit of alarming, but, I wanted to go a little bit further. And since the West Virginia DEP also sampled some streams, I wanted to sample the same stream sites a couple of years later, just to see what the numbers were. And at the same time, sample some of those other locations like the USGS well. Well, you can see on the screen, these three, Ebbets Run, Site 1 and Site 2 and Cold Spring Run, had extremely high levels of PFAS pollutants. And 137 parts per trillion, 168 parts per trillion, 1480 parts per trillion. So these are really high numbers. And remember, the drinking water standard was 70 parts per trillion. Now, there's a lot of information out there that says 70 parts per trillion is way, way too weak of even a standard for drinking water. It should more like be around 2 to 5 parts per trillion. So with these numbers in the stream, extremely high. And then following up with some research that the Air National Guard was doing on their groundwater studies. I mean, look at the groundwater component of PFAS, PFOA and PFOS in the groundwater around the site. We're at 126,000 parts per trillion. That's just insane over the drinking water guidance. So, my big question was, all right, if it's in this water, is it in the fish? Because I knew that, the fish are swimming around this water, and it's got to get into into the tissues, into the bloodstream, and connect to the proteins. So that's what led me to Vicki. Next slide. And, Vicki went through some of her research, and thank goodness that she was there and she had some of the information, because that really led the the breadcrumbs to the next tasks that I endeavored on in trying to figure out what's going on with PFAS. And the thing to note about the numbers from the initial information that Vicki gave me is that she's told the range of 220 to 574 nanograms per milliliter. Well, putting that into perspective of parts per trillion, which is really important to kind of give context, we're looking at 220,000 to 574,000 parts per trillion of PFAS. That is, and that's just insane. And this is in a fish species that, yes, has a large geographical range, but it's also a popular fish species that people will catch and will eat, and that's extremely concerning to me. Now, I've been told that this is in the plasma, The fish tissue will have less PFAS, but we don't know exactly how much in this area is just in the fish tissue. And so why is the PFAS so high? And these numbers were really high right there at the Antietam, at the mouth of the Antietam. So I'm like, well, why are the numbers so high? What is going on in the Antietam? And so I wanted to figure out what's going on. Next slide. And so we started taking a look at the Antietam Creek, the watershed, and tried to figure out, are there any hotspot PFAS sources? Are there any facilities that might be using these chemicals? And we really were scratching our head trying to figure out what is there, because we really didn't see any smoking gun. We really didn't. So what we decided to do was collect some water samples of some wastewater treatment plants, and then also at the Antietam Creek itself, to get some understanding of maybe there are sources coming in from the treatment plants. And sure enough, we got significant hits, 138 parts per trillion at the Hagerstown, which is a very large facility, 10 to 30 milligrams, millions of gallons per day discharge. And then the Smithsburg, smaller facility, 30 to 60,000 gallons per day, but also still very prevalent, 81. In the Antietam Creek itself, background noise, this is a 300 cubic feet per second at the time discharge, which is quite a lot of water, and that background level was 13.38 parts per trillion. And remember, I was talking about how some other states and some other research is suggesting 2 to 5 parts per trillion is considered toxic to the humans. And so, that's really begs the question, what is going on in the Antietam Creek? And if it's bad there, and at these two wastewater treatment plants, one that's in a rural area, but it is heavily developed. And then you have another, the Smithsburg, which is in a much more rural area. It's all residential, and it still has high PFAS. Where is that PFAS coming from? The only thing that that we're trying to figure out is there is a lot of PFAS coming from us, ourselves, the things that we drink and the things that we eat. We're excreting that through our waste, but we're also washing our clothes, using detergents, personal care products, and washing dishes in our dishwasher, our Tefal pans in the dishwasher, and all that stuff is, leaching off, and that's getting into the waste stream and into the river. Next slide. So I wanted to kind of put this in the context about loading, because that's kind of an important thing when you're looking at water quality. You have a sample that you can collect, and it gives you a concentration. Well, that concentration is how sometimes we look at water quality, but we also want to look at it in the context of loading. How much is being inputted into a system? And the PFAS loading from the Antietam, because it was collected right at the USGS gauge, we were able to use the discharge measured at the time of the sampling, puts it at about 7 pounds per year. So if that same discharge happened all year long, and that concentration happened, it was the same all year long, that would be the amount of PFAS that's being delivered to the Potomac River. And breaking it down from the Antietam, we just looked at PFOS and PFOA, and that's 1.5 pounds per year and 1 pound of PFOA per year. So this also got me thinking about questions, always questions when it comes to data. What's going on here? Well, what about the biosolids? And biosolids are then taken from these treatment plants. They're cured and dried, and then they're taken out to farm fields and put on the farm fields. Well, there's a significant problem here in Maryland because PFAS is not measured in biosolids. Next slide. So this brings us to MDE and MDE's progress, or I don't want to be crucial, but there's very slow. This drinking water guidance in 2016, that's 5 years ago. And MDE seems to be just now on the verge of doing a detailed assessment of drinking water facilities, public drinking water facilities across Maryland, to understand and figure out what the levels are and what that means to the citizens. But, after our water analysis of the treatment plants and the Antietam and the fish tissue numbers from Vicky, we submitted a summary report to MDE and let them know that, look, there's got to be more done than just drinking water. You really need to have a thorough, detailed plan to try and figure out what's going on. Because my concern is, besides the products that we're using on a day-to-day basis, which the bill and the delegates that are trying to pass through the legislature addresses one issue. It doesn't address all the issues. And we really need to understand what's coming from our treatment plants. We really need to understand, what's getting into all the different fish species that are out there, all the other aquatic species. One other issue that came up in the St. Mary's River in the southern part of the Potomac watershed is oysters. And there's a national air base down there. Trying to remember my notes here. And that would be the Patuxent National Air Station and Webster Field Annex. So there was some questions about PFAS violations and getting into the water and what is that doing to the oysters. And there's been some preliminary information from MD about the levels in oysters. They don't seem to be too high, but that's just one small component, one small area. And our push to MDE is we really need to know what is coming out of our treatment plants. We really have to know what's in the biosolids that are being put in our farm fields. And we really have to figure out and understand the levels that are in aquatic organisms that us Marylanders eat. And that's our goal. Our goal is to, help MDE push forward on this drinking water assessment so that we can establish finally in Maryland drinking water standards for PFAS, like other states have done, like Michigan, like California. They have established drinking water standards, not just following the 70 parts per trillion drinking water guidance that the EPA has set. We also want them to look into PFAS fish consumption advisories. Just like mercury, you can only eat so many per day. There really needs to be a detailed study about the PFAS levels in fish species, and something has to be done about developing an advisory so the public knows exactly what they're eating. And we really need to look into wastewater treatment technology that can reduce the PFAS. We have to stop the PFAS cycle. So, we're taking up water and we're excreting it in our waste and everything else. It goes in the treatment plant, it goes back into the river, it goes into the fish, goes in the water, and then it's just a great big circle. And we have to figure out ways to where we can put wrenches in that circle and that we can stop that cycle from happening. And then lastly, our goal is really to ban the use of biosolids that have high levels or any levels of PFAS in them. And it'd be interesting to find out what the levels are in biosolids here in the state of Maryland. With that, I think that I am done.
Thank you, Brent. We're just a couple minutes behind time, so I'll just hand it right over to Anna Kilias to tell us a little bit more about what's going on down in Virginia. Anna?
Great, thank you. And thanks everyone for sharing your Thursday evening with us. I'm Anna Kilias with the James River Association. We're headquartered in Richmond, Virginia. And I'll be touching on some of the PFAS work currently happening within the Commonwealth. Next slide. So starting with a snapshot of what we know about PFAS contamination in Virginia currently. We have known groundwater contamination on site in DuPont Spruance, which is in Chesterfield County. This is DuPont's largest manufacturing facility in the world, producing textiles like Kevlar, rayon, and Tyvek. We also have recorded contamination at multiple military installations, including Fentress Air Base, Oceana Naval Air Station, and Joint Base Langley, along with NASA's Wallops facility on our eastern shore. And then finally, we had 2 drinking water facilities in Prince William and Washington counties that detected PFAS in their treated water a few years ago when they were conducting nationwide monitoring for certain unregulated contaminants, including PFAS. These are just the areas we know about, but they certainly don't represent the full picture of contamination in Virginia. On the right, you'll see a map that's been produced by the Environmental Working Group, and it shows all the contaminated sites that we know about across the country. You'll notice that there are detections in every state, but there are notable concentrations in places like New Jersey and Michigan. And what sets those states apart is that they have taken the initiative to conduct pretty comprehensive sampling efforts of their water. And that tells us that PFAS usage has been so prolific that if you test for it, you will end up finding it. Next slide. So in 2020, we helped pass legislation that puts Virginia on the path to more testing and enforceable safety standards. Under the first bill, House Bill 586, Virginia's Department of Health has formed a work group of stakeholders, including JRA, tasked with a number of responsibilities. First, we have to conduct testing to determine the occurrence of PFAS in our drinking water. Second, we're asked to identify possible sources of PFAS contamination. And third, we are asked to develop recommendations for state drinking water standards that set the maximum levels of PFAS contamination allowable. We're focusing on the 6 specific types of PFAS listed here, because these are the ones that have a record of occurring in Virginia already. And our findings are due to the General Assembly by December 1st of this year. Timed to follow up upon that report is House Bill 1257. And this directs the State Board of Health to adopt drinking water standards for certain types of PFAS, as well as chromium-6 and 1,4-dioxane, which are 2 other types of contaminants that could pose serious health concerns. This bill comes into effect on January 1st, 2022. So it's going to follow upon the recommendations that we're trying to develop now. Next slide. I serve on the part of the work group team that's tasked with designing the testing protocols. So I thought I'd give a breakdown of what that testing may look like. In designing that occurrence sampling, we had a couple of priorities and a few limitations to keep in mind. Public health always comes first, particularly for the Department of Health. So we needed to look for any immediate risks to our largest population centers. And that means we have to test the largest waterworks. But we also wanted to make sure that we're casting a wide net that considers the potential PFAS hotspots across the Commonwealth where we could have contamination of groundwater and surface water sources already happening. We are limited by the legislation to only look at no more than 50 water sources, which is a very small subsection when you consider that there are roughly 3,000 waterworks across the state. And we didn't receive any state funding for this study. So we're working with a $40,000 grant from EPA. And that limits us to doing only 1 sample at each site and not really being able to do follow-up testing to confirm detections or find seasonal changes in contamination. So this testing is not going to be comprehensive, but it is going to offer us kind of a foundation for that future work we need to do. We're going to form the relationships we need. We're going to develop the testing protocols, and we're going to start learning how to identify higher risk areas and prioritize our work. Next slide. So where are we going to be testing? This is a look at Virginia's 17 largest waterworks, and many of these are going to fall within the state's urban crescent. So following I-95 from Northern Virginia through Richmond and then down into the Hampton Roads region. All told, these waterworks serve approximately 4.5 million customers. So we'll have an early warning if there are any immediate risks to more than half of all Virginians. Next slide. As for our groundwater sources that may be near PFAS hotspots, we've overlaid a map of the large commercial and military airports where firefighting foams may have been used, with a map of the unlined landfills that could be leaching PFAS contamination into the water table. And then we've looked for waterworks within a certain radius of either an airport or a landfill. As you can see with the red and yellow dots on the map, this offers us a bit more diversity in terms of geography of where we're testing and the population size of where we're testing. Next. And then finally, to add additional surface water sources near potential hotspots, we're looking at the facilities that are regulated by the Clean Water Act that may be releasing wastewater contaminated by PFAS. These could be significant industrial users that directly discharge into our waterways. On here, they're the little orange dots, or they could be municipal treatment plants that receive and treat industrial wastewater before releasing it into our rivers, which are identified in green. We traced along those river segments and looked for the water intakes nearby. Those are spots where our drinking water facilities are drawing water out of the river to be treated and sent to customers. So we're selecting a subset of those intakes here, kind of approximately the little red droplets, which will be tested. And that's going to help us reach more rural areas of Virginia places further west, further south, that otherwise wouldn't have been captured in the other two categories. Next. So that's all being done under the purview of the Department of Health. But I do want to note there's a couple of things that the Department of Environmental Quality is looking at as well. First, they're in charge of overseeing the remediation happening at DuPont Spruance. They've also been helping to identify historic and ongoing, potential historic and ongoing PFAS releases. They're conducting what they're calling a tabletop assessment of all of the information they have on file already to look at facilities that are involved in industries linked to PFAS, to look at airports where firefighting foams have been used in the past or may be used now. And then that information is going to inform both our drinking water study and then also if DEQ decides that ambient water quality and fish tissue sampling is necessary in those targeted areas. Finally, they're considering requiring permitted dischargers like those industrial users and wastewater treatment plants to directly test their discharges for PFAS contamination. The EPA recently released guidance that indicates that testing is both appropriate and authorized by the Clean Water Act. So DEQ is taking a look at whether they'd like to do that in the future. Next. So we certainly appreciate the ongoing work at the Department of Health and the Department of Environmental Quality, but we do have to stress the urgency of addressing PFAS contamination as quickly and comprehensively as possible. PFAS poses a risk to all Americans, but like other types of pollution, communities of color and low-income communities are bearing the brunt of the contamination. A report by the Union of Concerned Scientists found that low-income households and persons of color are disproportionately living within 5 miles of a site contaminated by PFAS, which suggests that these communities are already at a higher risk of exposure. Next. And we thought we'd look at just one of the known sites in Virginia here, DuPont Spruance, which is approximately where that little green triangle sits. And we can see that this rings true. The communities surrounding this industrial facility fall above the 80th, 90th, and 95th percentiles in terms of low-income population when compared to the rest of the state. So it's important that we're finding and monitoring these contaminated sites, remediating them if necessary, and that we're looking at all possible avenues of exposure for some of our most at-risk populations. Next. So that takes me to my last slide and my big ask. If you are a Virginia resident, here's one thing you can do today to help us ensure that the PFAS work group and our drinking water testing will be as effective as possible. We are asking Virginia's legislators to provide additional state funding to supplement the limited federal funds we have. With an extra $60,000 in funding, we can take multiple samples at each testing location, which will help us look at those seasonal changes in contamination and to do follow-up sampling if we have detections or anomalies. It also gives us the flexibility to use a newer and more expensive test that looks for more types of PFAS compounds. Virginia's Senate included $60,000 in their version of the budget, but the House didn't follow suit. So we're really asking the budget negotiators to follow the Senate example when it comes to this particular budget line. By clicking the link that I think Robin just dropped in the chat, you'll help us send a quick pre-written note to the negotiators that basically amplifies our message. But I would also ask one final thing, please personalize that message when you send it, because if you just drop an extra sentence in there about what safe drinking water means to you or why you're concerned about PFAS, that message will go farther. So I'll leave it there and I look forward to your questions.
All right, thank you very much, Anna. And also thank you, Brent and Vicky, for your presentations. We have a couple of questions in the Q&A box. None of them are directed at any of you specifically, so if you know the answer, feel free to pipe up. The first one is, what are some treatment technologies that are effective for removing PFAS from drinking water?
Right. So I can kind of comment on this one. With the Martinsburg facility, they had to put in activated carbon as a final step or interim step in their treatment process. And that seems to reduce the PFAS level significantly. Now, it's not 100% reduction of the PFAS chemicals, but it is a significant reduction. There are treatment technologies out there that can reduce it. Reverse osmosis is definitely one of those treatment technologies, but it's an extremely expensive process, especially your larger drinking water facilities that have millions of gallons that pass through that membrane. And, you know, then there's a question about maintaining and cleaning up the activated carbon and the membranes. What do you do with it? What do you do with that, that PFAS contaminated media?
Yeah, thanks. And actually, you know, that was a question that was posed earlier while the legislators were speaking, which was, if you can't burn the stuff and you can't landfill it, what's a good way to deal with it? I will put that question to you, but I also just suspect that it's one of those things where sometimes we come up with a way to solve a problem and create a pretty nasty chemical with a lot of unintended consequences that then just sticks around. And I don't know if I'm right about that. I hope that I'm wrong, but any of you can opine.
Right now, there's no silver bullet when it comes to figuring out a way to permanently dispose of these things or break it down into individual components so it's less benign. There is ongoing research to figure this out, and right, I think the concern is that it should be classified as a toxic material, and therefore there are specialized places where toxic materials do get sent to. However, the EPA has not designated PFAS or any of the individual substances under PFAS as toxic substance. So that's still an ongoing battle.
A comment in the chat feature said that there are some new sludge treatment technologies that use supercritical oxidation, e.g. 374 water. Maybe that's worth looking at. Don't know anything about that tech, but thank you for that comment. Another question was, how does the EPA's PFAS guidance limit of 70 parts per trillion stack up against other countries or states that have issued MCLs? And I'm not sure what that acronym stands for, probably concentration limits and something else, but
maximum contaminant level. MCL is
okay.
maximum contaminant level, which is in drinking water guidances. I know of a few. I know Michigan is the more recent one that has specific standards for drinking water for I think it's 7 substances in the PFAS family, PFOS and PFOA being the primary ones, and I believe they were all in single digits levels for standard at the parts per trillion level. So it's pretty significant. Michigan had probably the most restrictive of the other states so far that I've seen for PFAS.
Another piece that complicates that question and that answer, and it is complicating our work group's assessment of those different standards out there. There's 2 different types, right? You can have a regulation that actually is enforceable. You could have a health advisory that's just kind of when your drinking water source has to tell you that something has spiked. It could also be, is it a single standard for one type of PFAS, or is it the cumulative standard for all types of PFAS that they're testing for? And if they're doing it chemical by chemical, there are some chemicals where if you look at the limits out there, they're almost astronomically high. And so it's just really complicated. It could be as small as 6 parts per trillion or as big as 400,000 parts per trillion. So it is the devil's in the details with each state.
Thank you.
I'm sorry, go ahead, Jesse.
No, finish your thought.
Well, I was just reading the question and answer, and one of them was about how long is, which kind of goes into my pitch on this, is, how long has the EPA known about PFAS? And the EPA has known about PFAS for 3 decades. They've known that it's been an issue when DuPont, you know, when information about DuPont and 3M and all the other companies that were producing it were seeing significant problems. So they've had 3 decades to try and figure out a lot of these things. And, you know, there's many, many more, thousands more other man-made chemicals that just do not get the attention that they need. And with PFAS, there's 9,000 of them. So Anna is exactly right. It's just the devil is in the details. And I think that's one key issue about this legislation is that it directs the whole entire family of PFAS, not just a few of them. You know, because the big thing about the PFOS and PFOA is that the industry, the chemical companies, were starting to use smaller chain, but basically the same properties, and that can be just as carcinogenic and toxic to humans. And so, but they're still under that same larger family.
Thanks. Another question was kind of a logistical question for you, I think, Anna. If the state doesn't provide the $60,000 in funding, can that be crowdsourced? And if so, could state agencies accept that?
I'm not sure if crowdsourcing would work, but one of the things that we are looking at is if we could get the waterworks, particularly the large waterworks, to help cover the cost of doing the testing, which would kind of end up crowdsourcing it to their ratepayers, right? So if we could help the department out by kind of spreading the costs, which is, you know, a couple $100 per test across the different places being tested, that might be an option. But we are limited on time as well. So looking for other grant sources and other funding sources is just going to be a challenge no matter what.
Here's a good question. Have any correlations between PFAS and other co-occurring contaminants been identified? For instance, PCBs and PFAS or others that might help, I guess, with the testing cost and existing databases being put into play? Are any of you aware of anything like that out in the literature?
Nothing that I have seen. I don't know if, you know, I'm curious to hear what Vicki has to say about it, but nothing that I've seen.
Yeah, I haven't really seen, I mean, there's certainly some where, you know, when they look at that some of the PFAS from wastewater treatment plants that they can co-occur, but I'm not sure how that would help with the testing cost, because all of those things have to be tested separately.
Okay, another question in the Q&A is, would you advise anglers to reduce their consumption of fish caught in this region based on what we know about PFAS concentrations?
Well, I think it's a personal choice. We really don't have any information about, not a whole lot of information about what's in the tissue. Obviously, the plasma is quite high, so you can assume that the tissue is quite high. But in that, you know, we've only seen it in one species so far, and there could be several other species with higher or lower. You know, it's going to be a personal choice, kind of like mercury. I know me personally, I'm not going to. But then again, what about the fish that we get from the supermarket that's farm raised or what have you? That hasn't been tested either.
So there's a question that came up in the chat that kind of relates to something I was wondering too. You know, we've got this family of all these different kinds of PFASs, the question in the chat was, what is the contribution of cooking utensils or cooking products to PFAS levels? And that relates to what I was wondering, which is, are there certain applications where specific different formulations of PFAS are more likely to be found? Like, are you more likely to find PFOA in Gore-Tex and PFOS in Teflon, or how does that all break down?
There are some studies that have looked at specific compounds and sources. I can't give you all that information off the top of my head, but there definitely are. There's also been some studies that have looked at wastewater treatment facilities and the types of wastewater. So for instance, wastewater treatment plants that just have domestic waste versus those that have also some industrial and some domestic, and then the strictly industrial. And at least one of those studies, what they found was the ones with the industrial wastewaters do have higher levels of the PFAS, and the ones with just the domestic are somewhat lower. So there is some of that information out there. One of the problems is too, though, that some of the shorter chain ones can actually be metabolized into the PFOS. So it gets really complicated.
That kind of is a good segue into the next question, which was what analytical methods are best for PFAS testing? And I'd add a follow on, where do you go to get this stuff done? You know, like Brent, when you were collecting your samples, who did you take it to? And how much does it cost to get that kind of sampling done per sample?
Well, I know for us, we've gone to Pace Environmental up in Pennsylvania. There are several other places, labs that you can send your samples to, both water samples, soil samples, and biological samples. For the water samples, so far the costs have been around $400 per sample, and that gives you testing for about 8 to 13 different substances under the PFAS family.
And do we
And
know?
it's somewhat.
Go ahead, Vicky.
I was just going to say it's somewhat similar for at least for plasma. For 13 compounds, it costs us $355 a sample. We're going to go up to 24 compounds for the next round, and that's going to be around the 450.
And do any of you know what analytical methods are best, or what they're employed, like what the nuts and bolts of how those samples are processed is?
I think both Brent and I can tell you that there's a lot of QA, QC that goes into both the collection as well as because these compounds are in so many things, you have to really be careful when you're collecting the samples that you're not contaminating them either through the containers you're putting them in, the way you're collecting it. And then as far as the analysis, it's a mass spec is what most of the companies use. There are some other methods, but I think that's what most companies are using.
Yeah, so for the purposes of our study, we're looking at two different methods, so method 533 and method 537.1. And 537.1 is what we're aiming for. It tests more types, and including all 6 that we're looking at now.
And just to be clear, when you say method and list a number, you're talking about EPA analysis methods, is that correct?
Yes.
So another question here is, why test the plasma in fish and not the tissues? When do we get to the point where we are researching how it transfers to us when we eat the fish?
Well, if that's your question, is how is it transferring to humans and what's the human health aspect of eating fish, then you do need to look at the fillets or the muscle. My interest was, what is it doing to the fish? And so it's two different questions. The plasma, there were two reasons. One was that we had archived samples that we had readily available. The other was that plasma is, I mean, that's part of the blood. And so all your tissues are being exposed to that. And my feeling was it gives us, when we have those concentrations of what's in the plasma, that gives us a level to start with in the lab when we want to do some lab exposures.
Thanks. There's a comment in here also saying, I'm a toxicologist, and with respect to food products, you can go onto the FDA.gov website and type PFAS in the search box, and you will find some data there. Presumably that's in response to an earlier question about, how do we know what food products or what food containers are likely to have these chemicals in it? So thank you for that comment. Another question that popped up in the chat was, is landfill leachate tested for PFAS? And I presume probably the answer is yes in certain places. And I think, Anna, your presentation touched on some of that, right? Maybe you guys could put a little more color on that question.
Yeah, so I think that was an educated guess on DEQ's part. So we're looking at unlined landfills that, based on their waste streams, could have PFAS, something with PFAS inside and could be leaching it. That's not an indication that there is actual PFAS being tested for and found in those groundwater monitoring wells. It's not a hazardous substance. It's not listed as one. So it's not a requirement to be tested. If a facility is testing for it, that's probably based on the facility and based on their specific permit or what they're looking for.
Yeah, and that's a very specific problem with PFAS and the family of PFAS, is that it is not considered hazardous by the EPA, and so therefore even treatment plants weren't required or are not required to sample or test for it, or most industrial facilities are not required to sample for it because it's not considered hazardous. And so that's a specific problem. And I wanted to also go back to when Vicki was talking about sampling, and we have to be really careful because we're talking about parts per trillion, which is such a small amount of pollutant that can impact our bodies. And making sure that when we collect those samples that we are very, very careful about contamination. For instance, it's best when you collect a water sample to not pre-mark on the water bottle with a Sharpie, because a Sharpie has PFAS levels in it. And so if you mark on your sample bottle with a Sharpie before you take the sample and you collect the sample, there very well could be cross-contamination of that sample from the Sharpie. So, I mean, it's a very, very sensitive test. We're talking about small numbers here.
Yeah, it makes sense. I mean, Sharpies are water resistant, right? So
yep,
that's why they've got that stuff in them. I think we kind of touched on this question earlier in reference to how does EPA's guidance stack up against other jurisdictions, but in a somewhat different variation, are there any countries, states, agencies, organizations out there that you guys are aware of that have what you would consider a good, robust, precautionary kind of regulatory model for PFAS, either in fish, other foods, water, anything like that?
I don't think in our research that we've found, a specific place where we can point to a comprehensive plan that we like. I think there are states where we like certain pieces of what they've done, but then there are other things that they've chosen to do where we don't think it's protective enough, or maybe they've gone down the road of drinking water studies like Virginia will be, but they haven't turned to water quality criteria and fish tissue sampling and that side of things. So I don't think there's one, unfortunately, because this is an issue of emerging concern. we haven't been able to find one place where they've just done everything right and we can copy and paste that everywhere else.
Thanks. And you know, this when Brent, when you were mentioning that this is not classified as a hazardous substance, are you aware of any current ongoing petitions to EPA to have it listed as a hazardous substance, and what the status of those might be?
Well, I don't know of anything specific. I do know that EPA is still in their process of analyzing and figuring things out. In the last 4 years, that process got slowed down quite a bit, and we're hoping that that process speeds up in the next 4 years.
And I'll note that I think over 100 different members of Congress recently wrote a letter to President Biden and his new administration. I'm urging him to kind of pick up the pace on this particular issue, including listing it as a hazardous substance or working with them to list it as a hazardous substance. And he, during his campaign and his new nominee for EPA administrator, they've both reiterated that this PFAS will be a priority for them. So it'll be up to the community to really hold them to that.
Another procedural question came in about handling these samples, and asked, are the samples contained in glass then, because wouldn't plastic stand the chance to leach into the sample as well, or contaminate it also?
I can real quick take on that one. I know that with my sampling, I always have to produce a blank using the same container with deionized water. And then that blank has always come back with no PFAS in the level. So I don't really think that the sample bottles that we have out there that are plastic or have PFAS in them, because you have to remember PFAS is a coating that's applied to materials and things that protect the material from oils and from water and from everything else from sticking to that material. And so therefore, you know, plastic is not necessarily contains PFAS when they make that plastic for those sample bottles.
Okay, thanks for
Yeah,
that.
our tubes are polystyrene or polypropylene. I think you do have to be a little careful with the type of plastic, but again, you test that with blanks. And when we excuse me, when we first started, you know, we had to test whether our heparin that we're using as an anticoagulant it might be having an effect. So all those things.
A comment came into the chat noting that the UC Berkeley Law School has filed a petition for rulemaking with EPA calling on the agency to list PFAS as hazardous waste. So thank you for that update, Philip. Another question was about do you have a theory, or do you know how the PFAS are getting into the fish? Is it because that they are absorbed through ingestion or through the gills?
The lab studies that have been done have shown that most of it seems to be aqueous exposure, but that they probably are, particularly some of these higher trophic levels, are getting it through the diet as well. So I think it's both pathways.
Okay, thanks. And that makes sense on account of the bioaccumulation features of the chemicals, that the bigger fish would get at least a healthy dose from their food. Well, so that seems to have exhausted all of the questions we had, and not a moment too soon. We were supposed to wrap this up around 8:30. So I think now I can pass it back to Robin for the last slide and call to action.
Hi, yes. So the slide you see now has everybody's contact information. In the chat, we put links to various resources and action alerts. We will also follow up with an email to everybody who registered with those links and more resources and ways that you can get involved, and also a recording of this, so you can go back and really dive into the presentations, and we appreciate everybody being with us this evening, particularly the all of our panelists. We special thanks to Senator Sarah Elfreth and Delegate Sarah Love, and Vicki Blazer and Brent Walls and Anna Killius, and of course, Jesse Iliff for being our great moderator of this evening. This is going to be a long haul to address this issue of this toxic contaminant in our environment, in our waters. And we hope that you support the groups that are doing the hard work and support your legislators who are trying to pass the important laws to address this issue and help protect everybody's health in our communities. Thank you for joining us this evening, and we hope to see you again. Thank you.